Until now, most of our interactions with AI language models have been through text. We ask questions and the AI provides answers based on its knowledge. But what if AI could understand not just our words, but also our emotions? ChatGPT has served as a text-based large language model, or LLM, for human-AI interaction. Despite its impressive capabilities, ChatGPT does have limitations. At times, it struggles to fully grasp the meaning behind our words, or capture the subtleties in a conversation. It performs better when provided with accurate information from the start. Currently, when communicating with AI, we rely on text, lacking the nuances that humans use to understand each other, such as tone of voice, body language, and facial expressions. These elements help us gauge genuine emotions. Without them, AI might not always interpret us correctly, leading to responses that don't quite fit. Now imagine having a conversation with a computer that not only understands your words, but also senses your emotions. Microsoft has achieved a significant feat in the realm of AI with its innovative concept, Project Rumi. This breakthrough paves the way for improved dialogues with AI that closely resemble interactions with humans. Project Rumi aims to address these limitations. It strives to equip AI with the ability to understand not only the words we use, but also the manner in which we express them and the emotions we convey. Think of it as enhancing AI's grasp on human emotions. This initiative is fueled by the core concept of multimodal paralinguistic prompting. While it may initially sound like complex technical jargon, it can be simplified into a more accessible idea, empowering expansive language models to process not just text-based data, but also to assess and interact with the user's emotions. In practical terms, this means that when you engage with such a model, it doesn't solely understand the words you use, it also comprehends the underlying sentiments and emotions associated with those words. You might be wondering what paralinguistic prompting is all about. Let's proceed to the Microsoft research page on Project Rumi. It states, quote, Project Rumi incorporates paralinguistic input into prompt-based interactions with LLMs, with the objective of improving quality of communication. Providing this context is critical to enhancing LLM's capabilities in this AI as a co-pilot era. It continues, our current system leverages separately trained vision and audio-based models to detect and analyze nonverbal cues extracted from data streams. The models assess sentiment from cognitive and psychological data in real time, generating appropriate paralinguistic tokens to augment standard lexical prompt input to existing LLMs such as GPT-4. This multimodal, multi-step architecture integrates seamlessly with all pre-trained text-based LLMs to provide additional information on the user's sentiment and intention that's not captured by text-based models, augmenting the prompt with the richness and subtlety of human communication to bring human-AI interaction to a new level. The visual representation of Project Rumi provides a clear flowchart outlining how the system operates. It all starts with the user and includes both physical and non-contact sensors as inputs. Now, when we talk about these physical sensors, we're talking about those touch-sensitive devices that directly connect to you, collecting real-time physiological data. If you take a look at the diagram, you'll see it's divided into three primary categories. First up, there's the EEG, also known as the electroencephalogram. This amazing sensor measures and tracks the electrical activity in your brain. What's fascinating is that it offers the AI insights into your cognitive processes, how alert you are, and even your mental state. This helps the system figure out if you're concentrating hard, feeling relaxed, or perhaps carrying a substantial mental workload. Next, we have the perspiration sensors, also called galvanic skin response, or GSR sensors. These smart gadgets measure the electrical conductance of your skin, which changes based on its moisture level. Do you know what's intriguing? The amount of sweat your skin produces can actually provide the AI with clues about your emotional or physiological arousal. So, these sensors give the AI indications of whether you're stressed, super excited, or maybe just a bit fearful. Last but not least, we've got the heart rate monitor. Just like the name implies, this device keeps a close watch on your heart rate, observing its fluctuations. And you know what's fantastic? These fluctuations can reveal a variety of emotions and reactions. Your heart rate might show that you're relaxed or calm, or it could signal that you're experiencing anxiety or pure excitement. So, this comprehensive set of sensors, including the EEG, perspiration sensors, and heart rate monitor, helps the AI understand not only what you're saying, but also how you're feeling, taking human-AI interaction to a whole new level. Now, talking about non-contact systems. These are the kind of systems that gather information without actually physically touching the user. Instead, they rely on visual and auditory signals. The diagram lays it out neatly, showing three main systems that fall into this category. First up in the lineup is the camera system. It's designed with the purpose of capturing visual intricacies, with a special focus on zooming in to catch facial expressions, even those delicate micro-expressions. These expressions can be likened to tiny emotional clues. They unveil a wide spectrum of emotions, ranging from happiness and surprise to sadness or even anger. This is the mechanism that enables the system to accurately decipher your emotional state with remarkable precision. Moving along, we have the eye tracking system. This is quite a sophisticated setup that diligently tracks your eye movements and monitors what captures your gaze. Building on this data, it's able to make informed assumptions about where your attention is directed, what captures your interest, and it can even detect your emotional reactions to what you're viewing. For instance, rapid eye movement might hint a touch of nervousness or excitement, whereas a steady and unwavering gaze could signify deep concentration or profound contemplation. Lastly, we come to the speech analysis system. This system zeroes in on your voice. It takes note of the fluctuations in how you express yourself, your tone, pitch, and speed. These variations serve as minuscule emotional cues. They offer insights into whether you're feeling content, frustrated, uncertain, or radiating with confidence. This blend of physical sensors and non-contact systems creates a comprehensive picture of the user's emotional and cognitive state. This allows the system to customize its responses and interactions accordingly, resulting in a more intuitive and empathetic interaction between humans and AI. Microsoft provides a demonstration of the software's effectiveness through a video. They've integrated it into what appears to be a beta version of Bing Chat. In the initial screenshot, you can observe the user recording a video or audio, which is then transcribed and converted into AI-readable text. The user's emotional state is displayed as a pie chart, indicating emotions like happiness. The AI even detects a sense of disgust in the audio and labels the user state as neutral based on the video. As the video progresses, they explain how they analyze the audio to understand its content. The audio is divided into two parts, the text and the features. They employ two transformer models for this process, the first one being Hubbard. Hubbard is a self-supervised speech representation learning model inspired by the BERT architecture, originally designed for tasks in natural language processing. In simple words, Hubbard transforms raw speech data into a structure similar to language by identifying distinct hidden units, which can be compared to words or tokens in a text. Hubbard's primary objective is to enhance performance in tasks like speech recognition, generation, and compression. It accomplishes this by processing masked, continuous speech features and predicting predetermined cluster assignments. Hubbard's model architecture closely resembles that of Wave 2 VEC 2.0, with base and large versions containing 95 million and 317 million parameters, respectively. Another tool they employ is the transformer DistillBERT. DistillBERT is a more compact and faster version of the BERT transformer model, tailored for natural language processing tasks. It's developed using a technique called knowledge distillation, which trims down the size of the original BERT model by 40%, while retaining 97% of its performance. This makes DistillBERT highly efficient and suitable for situations with limited computational resources, including on-device applications. It finds utility in various natural language processing tasks, such as text classification. In a nutshell, the Project Rumi team is working hard to make our interactions with AI feel more natural, like talking to a real person. It's a significant step forward in the world of AI, and it's exciting to see how it will shape the future of human-computer interaction. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to this channel for more AI updates. Thanks so much for watching, and have an awesome day.